Hello students. Uh, in this first slide, you can see a picture of diamond, then a pencil which we use in our day-to-day life to write. Is it? And one small pouch which on which it is written as silica gel. This silica gel pouch you might have seen in your shoe box or even in some medicines. Is it? So what are all these? So first two, that is diamond and the pencil, that is made up of graphite. These are the allotropes of carbon, and the silica gel is made up of silicons, which is used to adsorb the moisture. Is it? So to remove the unpleasant smell from the shoe box, or to keep it moisture free, especially the leather shoes, is it, this silica gel is used. Even in some medicines, to keep the tablets dry, this silica gel is used. Yes, of course, I think you got the idea which topic we are going to learn today. Is it? Which consist of the carbon, silicon, etc. So all these elements comes in p block elements. Yes, my dear students, I am Mrs. Anjali Nadgouda, Department of Chemistry, KLS Gokte PU College, Belagavi. And today we are learning the new topic, that is some P block elements, which is of course the basic part of second year syllabus. In second year, again this topic is continued. So we have to start with the basic, and we should know the basic things, right? Okay. So let us start. In unit number 3, that is classification of elements and periodicity in properties, we have already learned about the overall periodic table, that is modern periodic table, which is based on atomic number, and hence we can remember the elements. In that topic, we have learned how the elements are grouped into in the periodic table, right? They are grouped either on their physical properties or on their electronic configuration, right? So on their electronic configuration, the overall periodic table is grouped into four parts that already we have learned. Is it? The first two groups, there are total 18 groups and 7 periods in a modern periodic table. Am I right? Yes. So first two groups are called as S block elements, that is alkali metals and alkaline earth metals. Then group number 13 to group number 18, we call it as P block elements. Am I right? So total how many groups are there in this? 6 groups are there, right? Then the middle part of this, that is the bridge between S block and P block, is called as D block elements, that is transition metals. And in that again one more part is there which is at the bottom of the periodic table. We call it as F block elements, which includes lanthanides and actinides. Yes. So we have already gone through this overall idea of the periodic table. Even in unit number 3, we have learned how the properties are changing, or they are periodic in function in the periodic table. How they are changes, how they are varying along a period and down the group. So this general study we have completed in classification of elements and periodicity in properties. Now we are going to learn the individual groups of each block. Okay. So the First study is S block elements and the second study is of P block elements. Now, for second year, the P block elements is important. So, I am taking first P block elements. And this P block elements, in last year we have one more thing we have studied, or one more statement we have studied, that is S block elements and P block elements togetherly they are called as representative elements, because many characteristics we can learn with these two groups, is it? And out of that, P block elements is very very interesting. Now, why it is interesting, that you will learn in next slide, or even in these P block elements, and how the properties are changing, what we have studied in general, and how it is varying for a particular group that we are going to study in this topic. Okay, so in this topic we are going to study only group number 13 and group number 14. The study is continued in second year from group number 15, 16, 17 till 18th group, that is last group. Okay, so let us have the overall P block elements, that is how it is, what are the properties, how they vary, that we are going to study from next slide. Okay, so here it is written as position of P block elements in a periodic table is group number 13 to group number 18. Okay, last year one more we have studied, that is blockwise electronic configuration, which we call it as general electronic configuration. In that we have studied for S block elements, the general electronic configuration is given as rare gas or noble gas, and NS 1 to 2, where N shows number of periods and S shows, that is S orbital, that is last electron enters in S orbital, and for every orbital the capacity of electrons, maximum capacity of electrons to accommodate is 2, and therefore S orbital can consist of only 2 electrons, and hence first two groups are called as S block elements. Like that, now P orbitals, there are total how many P orbitals? Px, Py and Pz, that is 3 orbitals. Each one contains 2 electrons. So maximum capacity is how much? 6 electrons. And hence, until we fill 6 electrons, the next electron will not enter in new shell. Is it? Or new orbital. Am I right? Yes. And according to that, this P block elements consist of total 6 groups, in which the last electron enters in each P orbital. So, what is the general electronic configuration of P block elements? Ns2, that is S orbital is completed, and Np 1 to 6. Now this electronic configuration is not there for only one element, and that is an exception, that is helium. So for helium, how much, what it is? Ns2. Okay, and it comes in group 18. Okay, now before going to study group number 30, each name of groups, we'll see one sentence. The variation in properties of P block elements is due to the influence of D and F electrons in the inner core of the heavier elements. Inner core means what? Inside. See, valence shell means last orbit or outermost orbit. Before that, whichever orbits are present in an atom, they are called as inner core. So these inner core orbits are filled either in D either in d orbitals or in f orbitals for the heavier elements, and this makes their chemistry interesting. Means what? See, these p block elements, they are showing variety in their properties. They are not similar. Usually we say the properties of the group, properties of the elements in one particular groups are very similar, right? But here this sentence is not true. They are showing very different properties in each group. And why it is? It is due to d and f electrons which are present in heavier elements. Heavier means at the when we move down the group, as the atomic number increases, the number of protons and electrons also increases, and these elements we say heavier elements. Okay, and because of this different type of different electronic configuration, their properties are also changing, or they are showing variety of properties, and this makes the chemistry very much interesting. So let us come to the variety of chemistry in p block elements. Now we'll see what are the names given to these group elements. Usually, as we know by our surname, so surname shows our family name, right? So here the first element of each group is called as, it represents the family of that group. So the names are given very interestingly, and they are group number 13 is called as boron family. Group 14 is called as carbon family. Group 15 is called as nitrogen family, which is also called as pnictogens. See, though the spelling starts with P, is silent, this pronunciation is pnictogens. Then group 16 is called as oxygen family, that is chalcogens. Then group 17 is called as halogens, and group 18 is called as noble gas or rare gas. Now, let us study the general trends in p block elements, that is general properties, how they are changing. In classification of elements and periodicity properties, we have studied some of the properties, how they are varying along a period and down the group. Out of that, the first one is atomic and ionic radii. What we say is, in short, as atomic size or ionic size. And in that, we have studied that along a period, atomic size always decreases, right? Why it decreases, we have already seen, because the newly entering electron or newly coming electron is added in the same shell or in the same orbit. Simultaneously, effective nuclear charge is also increasing, and hence the electrons in the outermost shell are dragged near to the nucleus, and hence the size decreases. So overall, when we study p block elements, there is the same thing is observed, that is along a period atomic or ionic radii decreases, that is from left to right. Now why this decrease takes place or decrease, we can see, because there is a progressive increase in effective nuclear charge, and this is what we have studied last year. Effective nuclear charge of the atoms while electrons are added in the same outermost shell. Okay, down the group what happens? Down the group, atomic size or ionic size increases. Why it increases? Yes, we know that down the group, as atomic number increases, every time the newly coming electron enters in new shell, right? So the effective nuclear charge decreases and hence the size increases. Okay. Yes. Now what about the other properties, that is ionization enthalpy, electron affinity or electronegativity? They are also having the same trend in p block elements, that is along a period increases and down the group decreases. Okay, but this is what we are studying is general. Now in detail we are going to study how it changes. See, this change is not regular in p block elements. There is little bit variation in each group, and that we are going to study in this topic. Let us see the metallic character. Along a period, metallic character decreases. Whenever we move from left to right of the periodic table, yes, metallic character decreases, whereas down the group, metallic character increases. Now, due to why it is? Due to increase in atomic size and decrease in ionization enthalpy. Down the group, metallic character increases because the outermost electron or the valence electron is loosely bound, and hence it is easy to remove the electron. And we know that the element, the element or the atom of the element which donates or which gives the electrons, we call it as metal, right? So as size increases, it is easy to donate the electron. Now what happens to the oxidation state? In last topic, we have learned what is mean by oxidation state. Is it? So usually what we say, the group number minus 10, it shows the oxidation state, and this oxidation state we call it as group oxidation state, which is common for that group. Is it? So maximum oxidation state, that is group oxidation state, is nothing but what? Total number of valence electrons. Now for these p block elements, it is the sum of s and p electrons. Why s and p electrons? Because we have seen the general electronic configuration for p block elements is ns2 np126. So outermost shell consists of s and p orbitals, right? And those can take part in bonding. Am I right? Yes. So p block elements may show other than this oxidation state, that is group oxidation state, which is normally differ from the total number of valence electrons by unit 2. Means it is usually 2 units less than the group oxidation state. Remember this. And this is due to inert pair effect. Again, what we have seen, that one statement, that is filling of D and F electrons in the inner core of the heavier elements make these changes. Okay. Yes, so we have seen the general properties of overall p block elements. Now we'll see the electronic configuration, their oxidation state, the first group, first element of that group, etc. So here is one table which shows group number 13 to 18, which is present in p block elements. Then general electronic configuration of each group: ns2 np1, ns2 np2, ns2 np3, ns2 np4, ns2 np5, and last one is ns2 np6. But for helium it is only ns2. This is an exception. Okay, now first member of each group is given. For group number 13, boron; group number 14, carbon; group 15, nitrogen; group 16, oxygen; group 17, fluorine; and group 18 is helium. Okay, now group oxidation state is given, which is we can calculate easily, that is group number minus 10. So 13 minus 10 is 3, 14 minus 10 is 4, 15 minus 10 is 5, 16 minus 10 is 6, 17 minus 10 is 7, and 18 minus 10 is 8. Okay, so this is group oxidation state. Along with that, these p block elements, they show even other oxidation state, which I told you, which may differ by 2 units less. Is it? So first group, that is group number 13 in p block, shows one more oxidation state, that is plus 1. 3 minus 2 is 1. Then plus 4 is plus 2 and minus 4. Like that, here it is plus 3 and minus 3. Plus 4, plus 2 and minus 2. Then plus 5, plus 3, plus 1 and minus 1. See these halogens, how they are showing variable oxidation states. And this we are going to learn in next year. That is in PUC second year. And group 18 shows plus 6, plus 4, plus 2. Now you may feel strange how these rare gases, they are showing different oxidation state. Yes, you will learn this in detail in next year. Okay, now let us start our studies with group number 13. Now, before starting the studies, or before begin to this group number 13 study, we must know where these elements, they occur in Earth's crust and in which form, right? So boron, the first element of group number 13 is boron, which is typically non-metal. See how the chemistry changes or how the properties are changing in one particular group. Usually what we see, the properties are remaining same. For example, in alkali metals and alkaline earth metals, they are showing similar properties for all the elements. But here, these properties are changing. Okay, so boron is typically non-metal, which is very rare element, fairly rare element, and it exhibits or it exists in two isotopic forms, that is 10 boron and 11 boron. I hope you know this 10 and 11 is what? Atomic mass number, whereas what is the atomic number for boron is 5. Is it? Yes. So 5b10 is one isotope, 5b11 is another isotope, right? Now how it occurs? It occurs as orthoboric acid, that is H3BO3. All of you are using boric powder, is it? So what is this boric powder is? It is nothing but orthoboric acid. Then borax, Na2B4O7. Here one more thing I have written, that is 4H2O. This shows it consists of water molecule, that is these are the hydrated salts. Okay, sodium borate, which is also called as, the chemical name is sodium borate hydrated. The common name is borax. So it occurs in very small quantity and always it occurs in compound form. Okay, now let us see the next element, that is aluminium. So this is a metal, but even it shows some similarities to boron, means it behaves like non-metal also, which we call it as metalloid. Is it? Then this is most abundant metal. Abundant means what? Which we get in maximum quantity in Earth's crust. That is called as abundant. So one more thing, this is the third most abundant element. Remember, when we see the overall periodic table, how many elements are there? Minimum 120 elements are there. Out of that, this is the third most abundant element, means third most in list which we are getting in Earth's crust. The first one is oxygen, second one is silicon, and third one is aluminium. So very much the occurrence is very large. That is called as abundant. Now how it occurs? It occurs as bauxite. Even it occurs in the form of mica. In Marathi we say it is abrak, is it? Which is used for decoration purpose. Bauxite, what is the formula? Al2O3.2H2O. And we are lucky enough because Indal factory is there in our Belgaum, is it? Which is the where the production of bauxite, where the mining of bauxite is done, or where the production of bauxite is done. Then next, cryolite, Na3Alf6, sodium aluminium fluoride, is it? So these are the forms in which aluminium exists. Now, where it occurs, in which cities, that is given, that is mentioned in textbook, please go through it. Even there are other forms also, but these two are the minerals of aluminium. And out of that, even bauxite is an ore of aluminium, means from which aluminium can be extracted. Now, what about the remaining elements? Gallium, indium, and thallium. These are metals and they are very rare, that is, less abundant elements in nature. Okay, so which elements are present in group 13? Boron, aluminium, gallium, indium, and thallium. So we are going to study the 5 elements in this group. Now this study is down the group, remember. So here symbol and its atomic number and its electronic configuration is given. You can just go through this. Boron is atomic number 5. We can write it as 1s2, 2s2, 2p1. But 1s2 is of what? Helium. Therefore we have written nearest noble gas is helium. Helium 2s2, 2p1. Then aluminium group atomic number 13. So here the electronic configuration is neon, that is atomic number 10, 1s2, 2s2, 2p6, and then 3s2, 3p1. Is it? Now in gallium, atomic number 31. So how you can remember this atomic number? Last year we have I have already told you the difference between this remains same, that is first difference is of 8, second difference is of 18, third difference is again of 18, and fourth difference is of 32. Is it? Okay. Then for gallium it is 31, that is argon 18, then 3d10. Remember why 3d10? Because in argon 3p6 is completed. So after 3p6 which comes 4s2 and then 3d10 and then comes 4p1. Okay. Yes. Now next indium 49, krypton again 5s2, 4d10, 5p1. So what you have observed in these two? 3d10 and 4d10, right? That is d orbitals are completely filled. This is called as inner core of the electrons, right? Now here d orbital electrons are filled. Now in thallium you just observe here d orbitals are also filled, that is 5d10, as well as even 4f is also filled, that is 4f14. So number of electrons increases, that is crowd increases. Is it? So there is a concept which we have learned, that is screening effect or shielding effect, which comes in all these three. And as this is variable, screening effect or shielding effect is variable. Sometimes it is very less or very poor, and sometimes it is what we can say larger. Therefore, their properties are changing, or there are differences, or there are variations in their properties. Okay. Now, in aluminium, you might have seen, just see here, 3s2 3p1. Though there is 3d orbital is present in third shell, but it is not filled, right? Then what you have observed for boron? Yes, boron does not contain d orbital, and hence boron shows different properties than the remaining all elements, which we call it as anomalous behavior. And in unit number 3, which we have seen that all second period elements, they are showing anomalous properties, and this we are going to learn in this topic. Okay. Yes. So this is about overall electronic configuration. Now from this, what we can learn, what we can predict is general electronic configuration of group number 13 is what? Ns2 Np1. Is it? Okay. Now let us study the variation in properties. How the properties are changing. Now we are going to study only for group number 13. Okay. So let us start with atomic radii. Usually what happens as we move down, as the atomic number increases, obviously the new electron is should enter in new shell, means the size should increase from top to bottom as the successive member increases. Is it? But here there is a small variation in gallium and indium. Sorry, gallium and aluminium. So aluminium is second element and gallium is third element. Actually, gallium should have the larger atomic radius than aluminium, but the reverse thing happens, that is atomic radius of gallium is less than aluminium. Now why this happens? We have seen the electronic configuration. Just see again, in aluminium there is no 3d electrons. Sorry, there are no 3d electrons, though 3d orbital is present in third shell, but 3d electrons are absent, whereas in gallium 3d electrons are there. And how many are there? Completely filled, that is 10 electrons. So innermost electrons, number of innermost electrons or inner core electrons are more, and hence there is a screening effect for the outermost electrons, right? But this screening effect is less, and hence the outermost electrons are dragged or attracted near to the nucleus, and hence gallium is having less size or less atomic radius than aluminium. Okay, so how we can give the reason? The presence of additional 10d electrons offer poor screening effect for the outer electrons from the increased nuclear charge in gallium. Okay, means if you see the table in textbook, you will come to know the size, atomic sizes are given for each and every element in this group. You can see from boron till aluminium atomic size increases, again from aluminium to gallium decreases, and again from gallium to thallium increases. Okay, so there is little variation in atomic radii. Okay, now let us see the next property, that is ionization enthalpy, which is totally depend on atomic size. Is it? Okay. So what we say usually, as atomic size increases, ionization enthalpy decreases. That is, energy required to remove the outermost electron is less. Now actually what should happen? As we move down, ionization enthalpy should decrease, is it? But here this decrease is not smooth or not regular down the group. Then what is the variation? From boron to aluminum, ionization enthalpy decreases. This is associated with increase in size. But there is discontinuity in ionization enthalpy values between aluminum and gallium and between indium and thallium. This now why it is? These variations are due to low screening effect to compensate the increase in nuclear charge. Okay. Now, what we can see one more thing is the sum of first three ionization enthalpy. First three ionization means to remove the outermost electron. We have seen that is for group number 13. How many electrons are there in valence shell? Yes, Ns2, Np1 means total 3 electrons are there. Means to remove these 3 electrons and to get the noble gas electronic configuration, it requires more energy. Means sum of first three ionization enthalpy is very high. And this affects, or the effect of this sum of ionization enthalpy effect of this ionization enthalpy occurs, or we can see in their chemical properties, which changes their chemical properties also. Okay. Then what happens to the electronegativity? Usually we are saying that down the group electronegativity decreases, and this decrease is continuous, but in these p block elements this is little bit changing. So in group number 13, electronegativity first decreases from boron to aluminum and then increases marginally, means very small, due to variation in atomic size of the elements. Okay. So these are the variations in periodic properties. Now we will study the physical properties of group number 13. As we have already seen that boron is typically non-metal, whereas aluminum is a metal, but sometimes it behaves as non-metal also. And remaining three elements, they are metal, right? Means metallic character goes on increasing down the group, whereas non-metallic character decreases down the group. Now let us see the another properties. So boron is extremely hard and black color solid. Now as it is very hard, obviously it has very high melting point, right? So unusually high melting point. Then what about the rest elements? Rest of the members are soft metals with low melting point and high electrical conductivity. We can see aluminum is used for the electrical wires, especially street wires are made up of aluminum, pure aluminum, right? Okay. Now let us see the specialities of gallium. Gallium is having unusually low melting point. It's just 303 Kelvin. I hope you know how to convert it into degrees Celsius, right? So how much temperature is there in degrees Celsius? It's just 30 °C. Means very small heat is sufficient to make it in liquid form, right? Or to convert it into liquid form. And that's why in summer season, usually in this hot season, gallium exists in liquid state. though it is a metal, it it occurs in liquid state, right? But it is having high boiling point. How much it is? 2676 Kelvin. And because of this high boiling point, it is used as material for measuring high temperature. So these properties can be utilized in day-to-day life. What about the density? Density of these elements increases down the group from boron to thallium. Okay, so in this topic, we have studied in this today's video, we have seen how the properties are changing from top to bottom, that is atomic size, ionization enthalpy, and electronegativity, right? And we have studied physical properties also. Let us continue with chemical properties in next video. Till that, thank you, and please be in touch of